This week's episode is brought to you in part by the ADA. Teeth tell a story. We know what ancient civilizations ate, drank, even where they lived, all from looking at their teeth. What story will your teeth tell about you? Your ADA dentist can help you find out and give you the tools to keep your teeth healthy for years to come. Use the American Dental Association's Find a Dentist tool to find the right dentist for you. Go to ada.org/sciencebag today. This week's episode is brought to you in part by Star Talk All-Stars. In a world filled with fake news, flat earthers, and conspiracy theories, what's a thinking person to do? Think like a skeptic, of course. On last week's episode of Star Talk All-Stars, neuroscientist Heather Berlin and her comic co-host Ari Schaefer investigated the importance of skeptical thinking with their guests Cara Santamaria and Stephen Novella of The Skeptic's Guide to the Universe. Remember, trust no one, question authority, and listen to Star Talk All-Stars, wherever you listen to podcasts for the rigorous scientific thinking you crave. Welcome to the Science Podcast for November 23rd, 2018. I'm Sarah Crespi. On this week's show, Megan Cantwell talks with news writer Josh Sokol about a fossil excavation site that's helping crack the Cambrian explosion. This is this incredible period of diversification of life that started about 540 million years ago. And I talk with James Hazel about his policy forum that proposes a universal DNA database for law enforcement. Would that be better than the public and private genetic databases in use today?
I'm Megan Cantwell, and I'm here with science writer Joshua Sokol to talk about his story, Cracking the Cambrian, which delves into life over 500 million years into the past. Hey, Josh.
Hey.
You got to join paleontologists on this really cool expedition to a fossil excavation site in the Kootenay National Park in British Columbia, Canada. So what was it like watching this process of fossils being excavated?
It's just incredibly scenic to be there. Campsite itself was extremely remote, a 4 or 5 hour hike if you were to get there on foot. You walk from there to the quarry, which is a tiny area on a very steep cliff. And the whole process is they've identified the rock layers that they want to look at. They're going to break big slabs out, cut the slabs up, and then they'll all distribute them around and have individual paleontologists chipping them open with chisels. And each time they break one open, there's the chance that inside there'll be some sort of amazing arthropod or fossil that no one's ever seen before. It's remarkable to see these animals being dug out and to see the gears spinning in the mind of the paleontologist looking at it and trying to say, what living animal created this? How could I reconstruct them? How are they related to any animal that lives today?
The creatures that they're finding lived in the ocean around 500 million years ago, but the fossils excavated were up high on this mountain. How did they end up there?
507 or so million years ago, what's now almost near the top of a mountain was a shallow sea. There's been just enormous kind of geologic upheaval since then, and orogeny, which geologists call the mountain formation process, pushed these up to where they are now, where they're peeking out of the side of a mountain.
Wow, which is really cool to see. And there are a bunch of places where these fossils outcrop throughout the mountains here. The fossils were discovered in a site specifically called, the unit is called the Burgess Shale, and this is a unit of rocks that researchers have been unearthing fossils from for decades. So why is this unit so great for excavating fossils from? What about it is so special that brings people back?
The unique thing about the Burgess Shale was originally that this was the best preservation site for this period, and all of these historic discoveries were made there. The recent discovery, though, that this formation extends is cool. It goes for miles throughout this mountain range, and you can pick different outcroppings of it. But what they found and what makes them come back is that when you go to different locations along this mountain range, different Burgess Shale areas, there seem to be different species. There seem to be different animal communities there. And so that gives enormous ecological value to understanding not just what one ecosystem looked like during this period, but a set of different ecosystems.
What about the specific site you visited was kind of interesting or unique then?
So this year, there's an unidentified arthropod fossil that hasn't been described, and it looks very vaguely like a spaceship. So that's what the team calls it now until they kind of devise a scientific name for it. And it's just an animal that's not known from other Cambrian sites, even in the Burgess Shale. But this summer, they found it for the first time, and they didn't just find one, they found it all over the place. It's incredibly common.
The paleontologist you quoted said it was the most extraordinary fossil, which means it should be pretty special, right?
Yeah. So they were finding these sort of spaceships all the time, and they found this one exceptional example, which is huge and intact and looks slightly different from the others. And so the team, of course, calls this the mothership. The spaceships are the small ones, and the mothership is the big, perfect one.
Why was there so much animal diversity during this time period? Is that something that they've gotten more answers to as they've explored this site?
There's sort of a global picture which is forming around this site, the fact that it's a different location than the original Burgess Shale location, and the fact that also paleontologists have found other locations that are really important for finding fossils from this period around the world. One school of thought, which is that this is a biological revolution where all these groups exist. And there's another one which says this is partly we're biased because this is a fossil issue, the fact that suddenly all of these things were fossilizable. So any explanation for the Cambrian explosion has to involve both these things. To what extent were the animals dispersing and spreading and diverging into different groups? And to what extent also was that preserved so well that it lasts over 500 million years later and we can study the individual species?
How have the fossils specifically from the Burgess Shale changed our understanding of evolution and animal life? Are there certain lineages you can see from these fossils that trace back to animal life in this day?
The major fossils in the Burgess Shale and the major fossils known from the Cambrian, the most common group, the most diverse group are the arthropods, which today we see insects and crustaceans. Crustaceans dominate the oceans, insects dominate the land. They're so diverse, but their diversity is only a fraction of the diversity, kind of disparity between different animals that existed in the Cambrian. So one thing the Burgess Shale shows is all of the different pan-arthropods, the things that we wouldn't even consider modern-day arthropods, but that were even weirder and stranger. That evolution kind of tried, and then ultimately those groups died out. Right. The other thing that's in the Burgess Shale that's really remarkable are early chordates, animals with a sort of a proto-spine. So our vertebrate ancestors are reflected in this valley. In a sense, when we look at this, we're looking at the origin of all of the most diverse and successful groups on Earth, including our own.
Are these conditions also found in other places around the world? Are we seeing more sites that reflect this Cambrian explosion?
So paleontologists believe that it's not an accident that there are so many amazing Cambrian fossils that preserve soft details.
What do you mean by soft details that are preserved?
These fossils have amazing things. They feature not just hard skeletons, but they have the eyes, the guts, they have nervous systems in some cases. There are certain exceptional fossils that seem to preserve brains and neurons from animals that lived over 500 million years ago. So it's really remarkable. And these are actually higher quality fossils than exist from almost any other time in the history of the Earth. It's kind of a weird paradox. They're some of the oldest animals, but they're some of the best preserved. One of the major theories is that there were sort of worldwide chemical conditions that made the Cambrian very conducive to producing good fossils. So imagine animals are dying, they're falling into a muddy seafloor, and there's not a lot of nutrients there for bacteria that would typically decompose them. So the bodies are left pretty intact. And the ocean chemistry is such that each layer of mud gets sealed and cemented off very quickly. So it's just sealed into rock quickly. The animals are preserved. This could explain why there's not just amazing fossils from the Burgess Shale, but also amazing Cambrian fossils from other locations that have been discovered in the last few decades.
Is there a lot of momentum right now in the research community to explore more of the Cambrian? And I know in your piece you mentioned that there are other study sites in China that are being explored as well.
There are a lot of sort of new fossil localities. The biggest one that's been developed in the last few decades is in China, where it's very accessible, and their sort of rival teams compete to find new Cambrian fossils and to find the exceptional ones, the ones that really show you how these animals ticked. Describing these bizarre animals and where they fit into the tree of life nets the scientists who do this, high-profile publications, and then there's the deeper sort of evolutionary mysteries as to why all these groups seem to jump into the fossil record at this time. They excavated many tons during the expedition I went to, and people have been going to the Canadian Rockies and doing this for over a century. And in China, there's excavations probably going on right this second. The vast majority of these fossils, they get analyzed, they get stored, but there's a great chance that people going back to the collections and looking to answer specific questions can find new things that the original people who dug the fossils out didn't even anticipate.
Thank you so much, Josh.
No, thank you.
Joshua Sokol is a science journalist based in Boston. You can find a link to his story at sciencemag.org/podcasts. Next up, Sarah Crespi talks with researcher James Hazel about the right way to set up a DNA database for forensic purposes.
This week's episode is also brought to you by Ops Jeannie. Incidents happen, and they require complex coordination between operations and software development teams who are putting out fires every day. That's why getting alerts immediately is critical. Thankfully, there's Ops Jeannie by Atlassian. Ops Jeannie empowers dev and ops teams to plan for service disruptions and stay in control during incidents. It also gives teams the power to respond quickly and efficiently to unplanned issues, and helps to notify all the right people through a smart combination of scheduling and escalation paths that account for things like time zones and holidays. Better yet, Ops Jeannie allows for deep flexibility in how, when, and where alerts are deployed, with over 200 integrations like Jira, Amazon CloudWatch, Datadog, New Relic, and more. Plus, it tracks all activity and provides useful insights to improve future incident responses. With Ops Jeannie, your next incident doesn't stand a chance. Visit opsgenie.com to sign up to get a free company account and add up to 5 team members. That's opsgenie.com, OPSGENIE.com. Never miss a critical alert again with Ops Jeannie. This episode is also brought to you by Bombas. Thanks to 2 years of research and development, multiple improvements in design, performance, and comfort, Bombas are the most comfortable socks in the history of feet. With an arch support system that provides extra support where you need it most and a cushioned footbed that's reinforced for comfort without added bulkiness, Bombas feel like a hug around your foot. Not to mention, Bombas Stay Up technology ensures your socks stay in place without leaving a mark. And the super soft cotton material makes you never want to take them off. So whether you're a runner, walker, lounger, there's a pair of Bombas that'll add comfort to your life. Go to bombas.com/sciencemag and use the code sciencemag to get 20% off your first order. That's Bombas, BOMBAS.com/sciencemag, code sciencemag, and you'll get 20% off your first order. Now we have James Hazel, a researcher working on the use of DNA in forensics. He's here to talk to us about the case for a universal DNA forensics database. I'm Sarah Crespi. Hi, James.
Hey, Sarah. Thanks for having me.
Sure. So we don't have anything like this now. We have government databases of DNA, we have public databases of DNA, and private databases like Ancestry or 23andMe, all with very different people inside of them and also different access rights. So how does law enforcement use these types of databases right now?
That really depends on the type of database that you're talking about. We began writing this paper in the wake of the revelations surrounding the Golden State Killer case, where you might remember law enforcement used a publicly accessible genealogy website. And that really prompted us to take a look at the current practices. And we came to the conclusion that, in essence, law enforcement essentially has a de facto universal database already when you look at the forensic databases combined with all the public and private databases.
To find the Golden State Killer, they pretended to be a consumer, submitted the DNA, and then found their relatives.
Yeah, that's correct.
They didn't need a subpoena or a warrant or anything like that to find this person's DNA.
No, they did so completely without court authorization, as you mentioned, simply by pretending that the DNA was theirs and uploading it under the ruse that they were hoping to fill out their family tree, so to speak.
Going back almost 10 years now, there have been op-eds. There was one in the New York Times. There have been policy papers and journals addressing this topic and asking the question, would a universal DNA database for forensic purposes be better than, how law enforcement uses genetic data? Is the Golden State Killer case really what prompted you to resurface this?
That's what got us thinking about the issue. But not only that, but also the rapid expansion of forensic law enforcement databases. A lot of people might know of CODIS, but each state maintains its own forensic database, and they're even creating now what are called shadow databases. That is for profiles that might not meet the criteria for the nationwide system, but that law enforcement might want to store locally. This raises a whole host of privacy issues.
For a while, it was people who were arrested and people who were in the prison system whose DNA profile was taken into the database run by the government. But now it's swabbing people they pull over in a traffic stop and then putting that into their local database.
Yeah, we've seen anecdotal reports of someone might be stopped by police and then asked to voluntarily consent to provide a sample. And although it is in theory voluntary, you can imagine there might be some coercion associated with that.
This is a good description of the landscape right now of how the police, law enforcement interacts with what DNA databases are out there. So what's the case for making a universal one where everybody is in it?
So in this article, we argue that if correctly implemented, a universal system would not only be a much more effective law enforcement tool and reduce the need to conduct these long-range familial searches, but it also would be less discriminatory and more protective of privacy than the current system. And there's a number of reasons for that.
Yeah, what do you mean by discriminatory?
Currently, if you look at the forensic databases, they're predominantly lower income minority individuals that are in these databases. That's likely why police had to resort to a resource like GED Match in the Golden State Killer case, where you see that in terms of direct-to-consumer genetic testing databases that use that type of direct-to-consumer data, those individuals are predominantly from higher income brackets and predominantly more white than your forensic databases.
That'll make it less likely to only be searching a certain swath of the public and also give law enforcement access to parts of the public that aren't typically in these databases.
Correct.
One thing that really struck me about this was thinking about genetic profiles from Ancestry.com or 23andMe. It's anything they can find in your genetic profile they're looking for. Medical, who you're related to, all that stuff. But if it were this kind of forensic database, it's limited to like a certain set of loci on the genome.
Correct. And that's critical to our argument. As you mentioned, when you're talking about data in the healthcare or research or direct-to-consumer space, you're talking about thousands or even hundreds of thousands of genetic variations, and they're often coupled with personal information like family medical histories. What we're talking about is collecting a very limited subset of genetic information, a dozen or so markers for law enforcement purposes.
They're strictly for identification purposes. They're not to tell you what color eyes someone has. They're to tell you whether or not you have a certain number of repeats in an area of a chromosome.
Correct. And that type of information generally reveals little to no sensitive health information.
You mentioned research and medical records just now. So how are those used currently by law enforcement? Are they accessible?
Well, under HIPAA, in most circumstances, a subpoena, as opposed to a warrant, is all that is generally required to access that information. In the research space, it's a little different. Recent law conveyed some extra protections to research participants and purports to assure individuals that their data is immune from court orders of that type. However, those are automatically granted only to research funded by the National Institutes of Health and other HHS entities, and might leave some private research unprotected.
Well, if there were a universal database, would you expect that some of these other avenues that the law enforcement has been using would be cut off?
Yes. In our paper, we make the argument that with a universal system in place, since law enforcement needs would be met, Congress or lawmakers should simultaneously severely restrict the ability of law enforcement to seek data from these other sources.
What other protections would you recommend if such a database were instituted?
One of the central protections that we call for, and this is related to the limited genetic profiles, is destruction of the physical samples once they have been analyzed and the data uploaded into the universal database. So this would be the cheek swab or the actual spit in a cup that police might collect. And this is crucial because it eliminates a main privacy concern when you're talking about a universal system, and that is that the government might have access to an individual's entire genome if they had that sample, and you would be worried that retesting would occur and that the genetic profile would be expanded beyond what was originally intended.
I think a lot of people will come back to the universal nature of this. In this country, in the US, there's very little universal anything. There isn't a universal database of fingerprints. There isn't a universal database of even driver's license photos, as far as I know. So how do you see it being taken up and discussed at the cultural level?
Certainly, I think there's going to be quite a knee-jerk reaction. As you mentioned, we do not have many of those national systems, but we do have a national Social Security number system. We do collect fingerprints and other biometric data from individuals entering this country. I think it's premature to disregard the idea completely, especially when you look at the current context and the current system that we have.
Do you mean that their privacy is invading in very different and more extensive ways than perhaps this proposed system would?
So really, it's a combination of the ability of law enforcement to get access to data in research, healthcare, or direct-to-consumer databases simply with a subpoena, combined with the current makeup of forensic databases, which tend to be skewed toward disadvantaged individuals.
Well, I think that it'll probably be a very long process to get anything like this in place, but this really does expose some issues with what's going on right now with the subpoena-only level of protection.
And that was really a central reason why we chose to write the paper. We felt it was putting the idea of a universal forensic database on the table would spur a long overdue debate about the deficiencies of the current system and, more broadly, our societal commitments to fairness and equal protection.
How do you propose that samples be collected for a universal database?
Well, the ethical objections to mandating that individuals who have done nothing wrong submit a DNA sample are certainly not trivial. There are a number of ways it could be accomplished, whether through a census-style effort or potentially even through forensic profiling of newborns, whereby you already mandate that they undergo some compulsory medical tests. We acknowledge that these raise some serious ethical issues that would certainly need to be debated during the implementation phase and ultimately resolved by lawmakers, which in this case would be Congress. It's also worth noting that concerns about coercion or invasions of privacy did not give legislatures, or for that matter, the Supreme Court, pause when authorizing the compelled collection of DNA from arrestees, even for, in many cases, relatively minor crimes.
Thank you so much, James. James Hazel is a postdoctoral research fellow at the Center for Genetic Privacy and Identity in Community Settings. You can read his policy forum at sciencemag.org. And that concludes this edition of the Science Podcast. If you have any comments or suggestions for the show, write to us at sciencepodcast@aaas.org. You can subscribe to the show anywhere you get your podcasts, or you can listen on the Science website. That's sciencemag.org/podcast. To place an ad on the Science Podcast, contact midroll.com. The show was produced by Sarah Crespi and Megan Cantwell and edited by Podigy. Jeffrey Cook composed the music. On behalf of Science Magazine and its publisher, AAAS, thanks for joining us.